So hello and welcome back. So in this in the previous video we were talking about this company A that has basically 100 stores, and it opens 50 new stores a year. So here I can take the year, which is t, as my input variable here. So if I have a function that wants to represent this 50 new stores a year, that means if 1 year has passed, I have 50 new stores. So 1 into 50 is equal to 50. If 2 years have passed, you have 2 times 50, which is equal to 100 new stores. So you get where this is going. So that basically means that this is your t, and the 50 new stores is simply multiplied by this. So this becomes 50t. So your f of t is equal to 50t. So this is only one part of the definition of this problem. So f of t is equal to 50t. That means if I put t is equal to 2, which means, for example, 2 years have passed, that means 50 into 2, which means 100 new stores have been opened in those 2 years. And I had already 100 stores here, so I add the 100 stores to this, simply to this as well. So this becomes my model. And to do this a little more neatly, so this 100 becomes my initial value for this linear function. This is of course a linear function. So this becomes my initial value, and this becomes my slope. And basically you can already see that your slope defines the rate of growth of your function. So this becomes something like this. So of course, so I have to pay more attention to my graphs. So let's say this is my initial value, so also my y-intercept, because when t is equal to 0, this becomes 50 times 0, which becomes 0, and so f of 0 becomes simply 100. So let's say this is 100, and your slope is 0. So that basically means that if I take this to be 1, and if this is 100, so this becomes basically 200, and this becomes 50. If I take from this point to this point, then it becomes 50 on this scale. So this becomes 50, and then 100 here, 1 here. So basically if I go from the slope 50 means basically rise over run. That means 50 rise over one unit of run, so that means 50. So now the run is 1, which is this 1 unit over here, and the rise is 50 units, which is, this is 50, this is 1. So this becomes the slope of your line. And then basically one of the points of the line is this point, the other point is this point, and then you simply connect the 2 points together. And this is f of x is equal to 50x plus 50x plus 50x plus 100. So this is the company A. Now I have another company, which is company B. I have to do another here. I have another company which is the company B. So company B, what it does is has 100 stores. It has 100 stores and expands by increasing the number of stores by 50% each year. Expands 50% each year. So this growth, as you can see, wherever you can see 50%, whenever you see the percent, that basically means exponential growth, because what happens here is that you have this company B, and let's say this is T in year, and this is your the number of your companies N of T, and if T is equal to 0, you already have 100 stores, and then each year, when you add 1 year to this, the number of the stores is 50% increased. So it's an exponential growth. So that means you have to multiply this into 1.5. If the number of stores is, if 2 years have passed, adding 1 to this again, you take this number of stores, 100 times 1.5, and then again you have to increase this by 50%. That means you multiply this by 1.5 again. And you can see where this is going. This is equal to 100 times 1.5 raised to the first power. This is equal to 100 times 1.5 to the second power. This is equal to 100 times 1.5 to the 0th power. And here your t is equal to 0. Here your t is equal to 1. Here your t is equal to 2. So you can write n of t is equal to a, which is your 100 stores, 100 times 1.5 raised to the power t. Now if your t is equal to 2, for example, if your t is equal to 2, it's going to be 100 times 1.5 raised to the second power, which is what we got here. So basically, now we want to compare these two companies together, and you can do another table, put both of them next to each other, and this is your year, and they have called it X, and this was stores, company A, this is company A, and this is company B. So your company B was, they have gone from 1, 0, 1, 2, 3, 4, and 5. Basically, there is no, so basically up to 3. So we calculated the other company as, we calculated that company A was f of x is equal to 50x plus 100. Company B was f, let's say, I don't know, g of x, call it. G of x is equal to 100 times 1.5 raised to the power x. And basically you can fill out these columns here if you want to, and basically what happens here is that, for example, I don't have enough time here, but let's do this. For example, if your x is equal to 0, here you have 100 stores. If your x is equal to 1, you have 150, then you have 200, then you have 250. But this exponential model, here you start with 100, and then you go to 150, you go to 225, and then all of a sudden, at x is equal to 3, this exponential model grows to 337.5 stores. So that's basically how you can compare them together. You can basically figure out what sort of rules you can find for those functions, and what sort of model you should use in order to describe that sort of phenomenon or that sort of behavior. So that's basically the whole story here, and again, this is the graph of the functions. This is the company B, which was the exponential model. You can see that up to x is equal to, let me see, up to x is equal to 2, there the outputs were almost the same. Up to here the outputs are almost the same, but from around 2 the outputs are, this function is growing in a the form here is uniform. It's a constant change, it's a straight line, but the exponential, the company B, which is the exponential model, is growing exponentially. And let me see if there is something important here to cover. And the domain for both of these functions goes from 0 to infinity. The range for both of them goes to 100 to infinity. And of course, because company B grows exponentially, the number of stores grows exponentially after 1 year. After year 1, company B always has more stores than company A. So this is also important. So here we said that if you want to grow the number of stores of this company by 50%, you multiply that by 1.5. And this is 1 plus 0.5, which is 1.5. If you multiply anything by 1.5, you're increasing that 50%. So that's basically, and we will do more of these examples to get to understand this better, of course. But here, please note that in this exponential function, 100 represents the initial number of stores, which we discussed earlier, and 0.5 here represents the growth rate, and 1 plus 0.5 represents the growth factor. So 0.5 is the growth rate and 1.5 is the growth factor. So that's basically these two terms that are also important here. So I'll see you in the next video.